everybody, this is Jonathan.
And hey, you guys, I'm Justin.
So we're just gonna make a little recording of the Lab 2 demo for those that won't be able to make it on Monday because it's Labor Day. Everyone who has labs on Monday will get credit. People on Tuesday, you might too, but I'd still go if you're watching this. So our little agenda, we're just going to do a quick overview of classes and more in general objects in C++. And we're going to hit a quick overview of Lab 2 and some demos to show you what we're talking about. And yeah, that's about it. Because we don't have class, you're going to have to do quiz 2 on your own. But make sure to use the Discord to ask questions if you really need help. And yeah. All right, let's get started. Why do we use classes? Classes are great. I know y'all touched upon them in Python, but really classes are just ways for the compiler and just us in general to store things as objects rather than a bunch of individual data points or information. And it really helps to be able to utilize higher level concepts. Like for Lab 2, you're going to be dealing with cars and then dealerships. And those become higher and higher level concepts, which contain things of their own. So as we build up, it's much easier to view things as objects and to store things in objects rather than having everything stored individually. And that really touches upon the point of it really helps with reusability, because instead of reusing a bunch of different variables, we're reusing one class which has these variables and has all this information within it.
I see. I think that hit it pretty well. Classes are I think the encapsulation aspect is really useful. Just any object that cannot really be represented just by like a string or an integer, and instead maybe multiple variables, you're gonna want to use a class for.
Hmm.
Um, Really all of the labs and projects throughout the rest of the entire year, you're gonna have to use classes.
Hmm.
So you'll understand them a lot better throughout the semester too. So yeah.
Yeah, definitely. All right, going forward, how do we actually write classes in C++? Well, we're going to have two different things. We're going to have header files and source files. Now, you should be sort of familiar with source files already because main.cpp is a source file. But the main difference between the two is we're going to treat header files as like the declaration of classes. They're going to hold very little actual code. It's going to just be declarations or functions of functions and declarations of classes and which variables it holds, things like that. We don't actually want it to contain code because we want that code to be in our source file, which is the definitions of all those declarations we made in the header file. There's multiple different reasons why we do this. It looks so much nicer. It's so much easier to debug. Uh, it keeps code condensed and where it's supposed to be, and many other reasons. But we're going to ask you to do it for this class. No, you don't have to. It definitely would work without it, but it will be easier for you writing it. It will be easier for us reading it and helping you. And you really should get in the habit for after this class for other classes and going into the real world. One of the main things I want to touch on here is that you need to include header files, like we've included libraries so far, like the string library or math library, any of those. You include header files in their corresponding source file, and that same header file in the main file where the classes that are written in it are going to be called. And you should never, ever, ever include CPP files. It might work sometimes, but it is never correct. We will be compiling the CPP files together. So the main.cpp file and any other CPP files will be compiled together to make the executable, not included in any other files. And we'll touch on that and we'll show you how that works during the demo. Justin, any notes here?
Really, yeah, I was just gonna mention that this will make a lot more sense during the demo. This might be kind of weird to understand now, but after we show it, I think it'll be a lot clearer. And we'll also show you both ways of splitting your classes into two separate files, and also how you can just write it in the header file. Yeah.
Yeah, definitely. All right. Going on, classes by themselves, either classes or structs or any just general objects, are good at holding data. But in order to really utilize this and treat it as more of a object we use in multiple different ways, we need to add a couple of things. So the first thing we need to add is the constructor. The constructor is telling the compiler how we want this object to be created. Now, there are default constructors, so sometimes you can literally just name the object and it's created. But for most objects, that really isn't good enough. Like a car, we need to know the name of the car and we need to know the make and model and the year and the color and all that stuff. So that would be a great place for constructor to be made. When we're creating the object, we would tell the compiler all this information, so the object is holding this information from the very start, right? And we're going to go over the different types of constructors in the demo. Default and parameterized. Default takes no information and just has a default way of how to make the object with no outside information included. And the parameterized is going to be, we're going to include some stuff as parameters when we're creating the object. For destructors, destructors, when we leave the scope of a function, so whether that be a function we call which creates an object in it, and then we don't care about that object after we're done with the function, and the function falls out of scope, or when we're in main and anything we call is going to stay in scope for the life of the program, the compiler needs a way to get rid of this memory at the end. So where we are now and using static memory, we don't technically need to delete anything because nothing is being allocated. And we'll talk about this later in class, but it's important to understand of the idea of the destructor now. The destructor is basically made to free memory that we have allocated. So that means it's cleaning up our everything we've done in the program, everything we've done with that class. So once again, it might be a little confusing of what we're talking about now. We'll learn about dynamic memory soon, and we'll just show you the basics of the destructors now in the demo. Getters and setters, aka accessors and mutators, they're basically exactly what they say. A getter would be a function in the class that when we call it, we're going to get something from the class. And the setters are going to do exactly what they say. When we call the function, it is going to set something within the class. And we'll see this in the demo.
Yeah. So I think accessors and mutators, I would want to mention that they're specifically useful for um, like either getting the value of a private variable or changing the value of a private variable, and you would make the
Mm-hmm.
accessor or mutator public function. That'll make more
Yep.
sense in the demo as well.
Yeah.
And
And I think so.
one more thing I wanted to mention was that I think you hinted at this, but for destructors, I don't think you have to use any destructors in
Correct.
this lab for lab 2. Just let you know.
Absolutely
You have to
correct.
feel
Yeah.
free to.
So destructors are going to be important going forward in the class, but right now we're just going to learn what they are and how to theoretically make them. You're not actually going to have to use them for this lab.
Yeah, there were a
And
lot
going
of
over forward, I know Justin literally just touched on this. So there's a couple levels of access that we can give to these classes when they create them. If anybody dealt with Java, it's going to be very similar to this. But basically, we have two right now that y'all need to know: private and public. Private means when it comes to variables or functions within the class, it means only the class itself can call the functions. You cannot, if you make the object is the only one who can make the calls to the function or edit a certain variable. You in main cannot call the function, right? These private functions can only be called by another function within the object. And we'll see that in the demo. Public, on the other hand, is exactly what you think it is. Variables called public can be edited outside of the object, and functions labeled public can be called outside of the object. So if you create the object, you can call the functions included in the object, and it will work perfectly. And we'll show you how this works in the demo in a little bit.
Yeah. I think that maybe the only thing is that this, just like a lot of the other topics here, might be kind of hard to understand just by looking at these words. But when you look at some code examples, it'll be a lot easier. They're really not that complex.
Yep.
That's it.
Yep. And one final thing. I keep saying classes. I think we should be saying objects, because in C we're going to deal with classes and structs. I bring this up because classes, everything is private by default. So we're going to have to explicitly say public if we want our variables or functions to be public. And structs are going to be the exact opposite. Everything is going to be public by default. And we're going to have to explicitly say private if we want things to be private in the object.
Yeah.
All right. Going forward, just going to touch on this static keyword. I don't think you'll have to know too much about this, but basically what the static keyword does is that when you call static on a variable or a function, you're saying that variable belongs to the class instead of any instances of the class you create. For example, in the picture, we have static float pi. What that means is if we set pi to a certain value and we create two different objects of math of this class called math, that variable pi is going to be the same across them, even though we only set it in one of them, right? Because it belongs to every single class rather than just an instance of this class, if that makes sense. Same things for the functions. They're going to be called across all the instances rather than just one.
Yeah. I think that also means that you don't necessarily need to create an instance of the class to access the variables and functions. I think you can use the scope resolution operator, which is like 2 colons. So I think you could do math : pi, and you would be able to access that variable without making an instance of that math class. Yeah.
All right, guys. Now getting into the demo, you're going to notice I have two files open here. I have the class.cpp on the left side, and the class.h on the right side. And going back to what we were talking about earlier, notice how I put pragma once up here. Pragma once should always be included in your header files. There's other ways to do it, but we prefer pragma once. And what pragma once is doing is it's saying, hey, if this header file is included multiple times, I only want you to look at the class.h once. That means if the main.cpp and my class.cpp both include class.h, I don't want my functions to be redefined twice because that will cause issues. So this line is protecting us from that. So of course, that leads us in. We now have to do #include on this side, our class.h. And this will connect the two to belong to the same thing. So this is now going to look for the definitions of everything within here. So let's go ahead and get started. Let's go ahead and make a class on this side. Just going to start off with the class keyword. And let's just call it superhero. Here. So it's going to look like this, and we want to open our brackets and just go ahead and go like this. So now we have a class. In this class, let's put some variables. Let's go public because we want these variables. Actually, sorry, no. Let's make this private. We want these variables to get secret. So we're going to say string name. Oh, we're missing something here. Using namespace std. And I think we also have to hashtag include string. And are we working now? Identifier string is undefined. There we go. All right, now we have a string called the name. Let's just do an int called the age, and then maybe let's do another string called powers. Right. So now we have the superhero defined by his name, his age, and his powers. I say his. That's insensitive of me. Sorry. Let's go ahead and make some functions for this superhero. We're going to have them as public functions because we want to be able to access these functions outside of the superhero itself. First thing we want to do, let's make a constructor for the superhero. So a constructor, let's start out with a default constructor. This is just going to be making our most basic superhero there is. So we're going to start off like this, calling the name of the class and put parentheses, like we're making a function, because that is what a constructor is. It's a function calling the class, telling the class how to make itself, right? So in the header file itself, I don't want to define anything. I just want to say what's going to be in this class. So we're just going to put a semicolon here, and that is our constructor. Now it's I'm in VS Code, and I think CLion will say this as well. But see up here, function definition for superhero not found. That is because we've only declared the function. We have not defined it yet. That's what we're going to do in the CPP file over here in a second. So let's add some more functions before we get going. What else? Let's make a setter. Or sorry, no. Let's make another constructor. Let's make a parameterized constructor. So in this case, we want to be able to set his name and age, perhaps. So we're going to go string name and int age. So you may wonder, okay, you now have two constructors. How does the compiler know which one to call when you use superhero over here, for example? Well, that's the beauty of a default constructor versus parameterized constructors. What you put in when you call the function determines what version you use. So if I go over here and say superhero Henry, that's going to create an object, Henry, that is a superhero, right? And it's going to call this one right here because we have not defined, we have not put in the correct things over here. But if we come over here, actually, I hate the name Henry. Let's do Superman. So now let's put into this his name. So we'll do Clark Kent, and then his age. We'll do 27. So this is now calling this constructor because we've put in the string and the age. If you were to only put the name, that doesn't exist. That's not a constructor we have defined how to use yet. Vice versa for the age. If we only put in the age, that is a constructor we have not defined yet. We only have definitions for nothing at all or a name and an age. And you'll come across this later, but that's really the gist of it. You can make as many constructors as you want. They just have to have different functionalities between them. They either have to take a name and an age, or just an age, or just a name, or all three of them. It doesn't matter. It's just they have to be different so the compiler knows which one to call. So there's our default and our parameterized constructor. Let's go on to a setter. So say I want to set his powers. So we're going to go void because I don't actually want this function to return anything. And we'll call it set power. And we're going to take in a string called power. And this function is going to change what the powers is stored in the string, right? And then let's just make a function called, let's see, int, or we'll do string get name. So it's going to be a getter. We don't actually need to give it anything. It's going to give us the string, right? That's our return type. It's going to give us a string. Yeah, so let's go ahead and actually define these functions we've made. So going to the CPP file, we're going to go ahead and define the functions we're making. So the first thing we're going to start off over here is we're going to have to say where we're working in, right? So normally, if you were defining a function like we did previous, where you called a function in main, you had to define it before main was called, right? But you were working in the same CPP file, so that was all neat. You didn't have to do anything. Here, we're working across files, right? And we want to edit this function specifically. So we have to define that we have to tell the compiler that we are working on this function specifically. How do we do that? First thing we have to do is we have to name the namespace, right? The namespace is basically, in this case, the name of the class. So we are working within the superhero class on the superhero constructor with no parameters, and let's go ahead and define it. So in this case, we want our default name to be Clark Kent. We'll just make Superman our basic one. So we're going to say name equals Clark Kent and age equals 27. And that's it. That is the default constructor. Powers can be left blank, and we can change that later. But this is our basic superhero. Now let's go on and make our parameterized constructor. So we're going to go here. Exact same thing we did before. We're naming the name where we're working in and the name of the function. And then we're going to go ahead and string name because we're taking in a name, and int age because we want the age as well. All right. Inside of this, we're going to have to do an extra step here. Because if you notice, the parameter is called name, and the string we're working on is also called name. How do we get around that? Well, there's a special keyword called this. Now we're going to get into what this actually means when we hit pointers. But for now, just think about this saying the variables or the functions within the class. So this name, aka this variable right here, is equal to name, or the parameter we're getting from the user, right? And same thing over here. This age equals age. And that's it, right? Very basic. Let's go ahead and go to set power. So before, we did the name space first because these constructors don't actually have a return type. They're not void, they're not string, they're not anything. They're constructors, they're special. But now we're working on a void, right? So we know our return types. That's the very first thing we have to say. And then we have to specify the namespace again, superhero, and then the function we're working on, set power, string power, and our brackets. So what do we want to do in set power? We want to say this power, or sorry, powers. Let's make that the same on both. Equals power. So basically the exact same thing we're doing in the constructor, but with the setter, we can call this as many times as we want, right? Where we can't actually edit the name and the age of the superhero outside of the constructor. Right? And finally, let's do the getName function. So we're returning a string, working in the superhero namespace on the getName function with no parameters. Open our brackets, and we'll go ahead and do return our name. And that's it for that. All right, now I've go ahead and made a basic main.cpp, just a main function. Up here, you can notice I've included class.h. This is to include this, which utilizes the class.cpp. So let's go ahead and actually utilize our superheroes. So I'm going to make a superhero object, and I'm going to call it Superman like I did before. Our very basic default constructor. We don't provide it with anything. It's just going to have a name and age, which we've decided upon already. That looks weird. All right. Let's go ahead and see out something just to show you how this works. So we're going to go to Superman.getName because we are going into the Superman object, the superhero class, and running its getName because that getName belongs to Superman. It comes from the superhero class, but it belongs to Superman. So if we go ahead and open up a terminal, I think I have one already. So we can do G++. Let's name the file test, and let's include the CPP files we need to use. So it's main.cpp, because that's one we're actually going to be running. And then we also need to include the class.cpp. And this is what I meant earlier when we are compiling when we are compiling the CPP files together and not the header files. Notice the header file is not going to be down here. It is #included up here, and it is never compiled. Similarly, the CPP files will always be compiled down here and never included up here. It will solve you so many headaches if you just do this. Let's go ahead and make it. So now we have made the object, and let's run the test. Clark Kent is our printed name. Beautiful. All right, just to show you how public and private works, I want you to notice that we used the getter here. We didn't actually access and go into Superman and get his name, and I'll show you why. So let's go and see out Superman.name. Weird. It doesn't even pop up. Wonder why that's happening. Let's hover over it. Superhero name is inaccessible. That's weird. I wonder why that is. Let's go ahead and compile this again. Boom. Error. Superhero name is private within this context. That's saying we can't access the name outside of the object itself. That is what private is used for. That is why we use getters and setters, because we want to access those variables in other functions. And to do that, we'd need to use our getters and setters rather than just accessing the variable by itself. All right. So let's go ahead and use our parameterize constructor and change something. So let's go ahead and make another superhero. Let's go superhero the Flash, and let's give him a name, Barry Allen, and an age. You will call him younger. He's 18. He's a young guy. All right, and let's see out his name. Show you that it's going to give us Barry Allen rather than Clark Kent. Just a new line at the end of there, and we'll go ahead and run it. Compile, run the executable. Boom. Clark Kent, and then Barry Allen. Running the Superman, and then our Flash. All right. Now let's go ahead and set our power. Now I just noticed that we didn't actually make a getter for our power, so we're never going to read it. So let's make one real quick. Get power. And then up here, string superhero get power, takes in nothing, return power. Super easy. You can get really fast at this. Now let's go ahead and edit the Flash's power. So we're going to go flash.setPower. We're going to put in super speed, and then we're going to immediately print out his power. So flash.get power, and a new line character, and let's compile and run it. Compile, and let's run. Boom. Clark Kent, Barry Allen, and super speed, because that is the power we just set him. And yeah, just one final thing before we go over the lab, quick overview of the lab. I want to touch on destructors. And like I said before, you don't actually have to use destructors for this lab, but you will going forward, especially in Project 1, because that's utilizing memory. But I'm just going to show you how to make it here. It's very simple. Just like the constructor, it doesn't actually have a type. We're just kind of overriding what the compiler would normally do. So the first thing we're going to do is put a little tilde here and go superhero. right? Same exact thing we did for our constructor. It's just this little tilde means that it's a destructor now. What we'd normally do in our destructors is, okay, well, first of all, like I said before, I am declaring everything here. So I'm declaring our variables and declaring our functions here and defining their uses over here. But you can also just declare and define them over here. It doesn't hurt you. It just really only helps you to do it in the CPP file. It'll take a little longer. And sometimes I think on tests, if they want you to write a function for a class, you just do it purely in the header file. But we do want you to do it in the CPP file when you have the capability. So I'm just going to go ahead and make a simple destructor here. So this is really what a destructor looks like. And say we allocated space and memory for the name variable. I just go ahead and delete it here. So delete name. That's not exactly how it's going to look because this is wrong when we're actually deleting allocated space. But this is basically what a destructor is going to look like. We're going to call it, it's going to delete all the allocated space. And yeah, that basically should be it for the header file. We're going to go over a quick Lab 2 overview. And yeah, Justin.
This is going to be a quick Lab 2 overview to maybe help you get started. So here's the PDF here. You can open it inside of Codio like this when you click on this link. But it might be easier to like open it in a new tab or something like I have here. So yeah. So looking at the screen, first of all, there's 3 parts to this lab. And I think that the PDF mentions the 3 parts here like this. But basically you'll do part 1, and when you're passing these test cases here, then you'll click this arrow to go to part 2. And then once you're passing these test cases here, you'll click the arrow again and you're at part 3, and it's the same thing. So yeah. And I would definitely recommend completely doing like part 1, then part 2, then part 3. Some other things are that in part 1 specifically, what you're doing in this lab is you're writing these classes basically, like in vehicle.h and vehicle.cpp, you're writing a class. And then part 2, you're writing another class called showroom, and in part 3, you're writing another class called dealership. So when you move through the parts, you get more files on the left, like that. And that other thing that I was mentioning is that in part 1 here, you have to write some code in main.cpp with this vector. It's really easy. It's like a couple lines of code. And I think another thing is that when you go to part 2, the way these test cases work is kind of weird. So where this check it button is like using the test cases that are written in this main.cpp file. So what you need to do is like you need to click this button, code to replace the main.cpp. So when you start part 2, you'll copy this and then you'll put it here and you'll replace what was there for part 1. So definitely do that after you finish and pass these part 1 test cases. So yeah. And I'll briefly go through this PDF and talk about it too. So the first part of the lab is you're making that vehicle class. Also, this PDF has so much information and it's all really helpful, so definitely take advantage of that. It also has information that you need to know, like telling you what to do. So yeah, but you can see vehicle class. It tells you the variables that you need. You're going to want to make these private, and it also tells you these functions that you need to make in the vehicle class. These would be public. And I think that definitely the functions need to be named exactly like this. Like it needs to be get price with a capital G and a capital P, because the test case in main.cpp is using that. So yeah, like for instance, this display function with a capital D, it probably says it here. Yeah, displayed with a capital D. So you have to make it exactly like that. And it also sort of says what you have to do in these functions here. It's pretty straightforward, especially vehicle. Default constructor, you're going to assign it these values. So in this default constructor, you're going to use those. Yeah, vehicle is pretty straightforward. And one other thing that you'll do at the end of part one is I think you just put some vehicles in this vector. And doing this also helps you sort of get adjusted to part two, because in part two, the showroom, this is what we have. And you can see that, I think here in the showroom, you're now storing a vector of vehicles. So that's like a list of vehicles. And so in each showroom, there's multiple vehicles. Um, Yeah, that's pretty much all there is to it. And again, it shows you, I think, the variables, like the name of a showroom would probably be a string, you know. Um, Parameterized constructor, this accessor for the vector of vehicles that is here, and some other functions here. And it also explains the functions here. So yeah. And then dealership is like another level of abstraction out, I guess. And it's sort of the same thing. So the showroom had a vector of vehicles, but now I'm pretty sure the dealership, I think, has a vector of showrooms. Yeah, and again, here are these functions, and it tells you what to do here. And over here are some other tips and stuff, especially these little thingies are quite helpful. So definitely look through these based on whatever part you're on. And yeah, that's pretty much all there is to it.
Yeah, and just like your quizzes, once you're done with the part one, make sure to hit that arrow in the top right corner to go on to part two,
Mm,
because otherwise you'll be doing a third of the work, and you want to make sure you do all three parts to get full credit.
definitely, yeah. Also make sure to mark as complete when you're done.
Yeah, make sure you hit check it on all three. If you change something so that when you check it, it no longer gets points, I think we've been over this, but it does not keep the best one you've done. It only keeps the most recent. So you want to make sure everything is perfect before you hit mark complete. You want to make sure you check it before you hit mark as complete. Otherwise, it may not be the result you're expecting.
Yeah, definitely. And sort of a weird thing about this replacing the main.cpp file is that once you finish part one, you're gonna want to not click this button again because the test cases that are in main.cpp are different. And if you click it again, it's like a little annoying because you gotta get the old one. So just once you're passing them here, just don't click the button again, and it'll make your life a little easier. And remember, the code for each main.cpp in the next parts is here under this little thing. You click this button. It's here. So yeah.
Yeah, I think that's about it for today. If y'all have any questions, please feel free to reach out over Discord, whether that be on the server, for the forums, or to us directly. We may take a little more time to respond to you directly, so the best place is definitely that forum question on the Discord channel. But yeah, we're all here to help, and good luck on the lab.
Yeah.